Good day! For today's video, we're going to have the graph of rational functions. And the learning objectives are the following. Determine the intercepts, zeros, asymptotes, and dominant range of rational functions, and graph the rational functions. The algebraic analysis of rational function facilitates its graphing. The technique in graphing rational functions includes finding the asymptotes, intercepts, zeros, and domain and range of the rational function. But let us define first what an asymptote is. So when we say asymptote, it is an imaginary line to which a graph of a function gets closer and closer as it increases or decreases its value without limit, but it will never cross the graph. So it is an imaginary line. It will not touch the graph. Now, the graph of the function r of x is a continuous smooth curve with breaks that occur at the value of x where it is undefined. So you will find here a hole or a gap on the graph because of the values of x that will make the function undefined. So there will be a hole on that part of the graph. There are two types of asymptotes, the vertical and the horizontal asymptote. So to determine the vertical asymptote of a rational function, r of x, you're going to find the zeros of the denominator that are not zeros of the numerator. To find the zeros, all you have to do is to equate the factor of the numerator and denominator to 0 and solve for the value of x. That will be your vertical asymptote. Now, for the horizontal asymptote, you're going to compare the degree. When we're talking about the degree here, we refer to the exponent. So we're going to compare the exponent of the numerator and the denominator, and then we will represent the degree of the numerator by n and m by the degree of the denominator. Now, if the exponent of the numerator is less than the degree or the exponent of the denominator, then we only have the horizontal asymptote, which is the line y is equal to 0. Now, if we have the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is simply y is equal to a over b, meaning this is the leading coefficients. Okay, a and b are the leading coefficients of the numerator and denominator respectively. So that is the numerical coefficients. Okay, but if n or the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Okay, another term that we're going to need in graphing the rational function is the intercepts. So when we say intercepts, these are the points on the graph that crosses either the x or the y axis. Now, the x-intercept of the graph of the rational function, if it exists, occurs at the zeros of the numerator that are not zeros of the denominator. So x-intercepts and vertical asymptotes are the opposites. Okay, they are opposites of each other. So x-intercept zeros of the numerator that are not zeros of the denominator, while vertical asymptotes are zeros of the denominators which are not zeros of the numerator. Okay, so that's why they are opposites. Or we can let the value of y equal to 0, and then we can solve for the x-intercept. Now, for the y-intercept, all you have to do is to let the value of x equal to 0, and then we solve for the value of y, provided that r of 0 is defined. Okay, so that is how we're going to get the intercepts. Next is the zeros of a rational function. So the zeros of the rational function r of x is equal to p of x divided by q of x can be determined by solving p of x is equal to 0, meaning we're going to equate the factors or the expression in the numerator to 0 and then solve for that. Okay, so in other words, whatever values that make the numerator p of x equal to zeros are the zeros of the rational functions. Okay, So these are also the values of the independent variable that make the numerator 0, but it is not a restrictions of the rational function, meaning it is not the value of x that will make it undefined. Okay? To complete our graph, we will also be needing the domain and range of the function. So we discussed domain before as the set of all x values in the set, while the range is the set of all y values in a set or in a relation. Now, for the domain of the rational function, that will also be the set of all possible values that the independent variable x can take, while the range is the set of all possible resulting values of the dependent variable f of x or y can take after we have substituted the domain. Okay, generally, the domain and range of a function is the set of all values for which the function is defined. Specifically, if we have a polynomial function, the domain and range is simply the set of all real numbers. For example, we have y is equal to x plus 3, so this is a linear function. You can have any values for x and y. So that's why it is the set of all real numbers. There is no restriction for a polynomial function, even if you have a quadratic function, a cubic function. Now, for a radical function, the number under the radical symbol must always be positive, or the radicand should be positive. For example, you have y is equal to the square root of x minus 1. If we substitute any values for x, the resulting value should not be negative. So here, for the resulting value to always be positive, we can have a x should be greater than 1. Greater than or equal to 1. So we can have 0 but not negative. So if we substitute greater than 1, for instance 2, so you will have 2 minus 1, that is still positive. So all the values greater than 1 will be the domain. Same goes with the range. So you just have to solve it. Now, for the rational function, which we will be dealing today, the denominator of the fraction should not be 0. So, for example, you have y is equal to 3 over x minus 1. So, the value of x here should not make the denominator equal. So, here, should not make the denominator 0. So, here, the value of x cannot be equal 1. Since if you have 1, you will have 1 minus 1. So, that will be 0. So, your domain and range here, your domain specifically, will be any value but not equal to 1. So, all real numbers except 1. Okay, so that is how we find the domain of a rational function. There is always a restrictions in the denominator. Here, there is a restrictions in the radicand, but for a polynomial, there is no restriction. I hope that is clear. Okay, so this time let us discuss the steps in graphing rational function. For example, we have graph the rational function f of x is equal to x squared minus 4x plus 3 divided by x squared minus 5x plus 4. So the first step is to factor the numerator and denominator of the rational function if it is not yet reduced to simplest form. But if it is already reduced to simplest form, you can proceed to step number 2. But since this one is not yet in simplest form, so we're going to factor the numerator and the denominator. For the numerator, we will have the factor x minus 3 and x minus 1. And then for the denominator, we have x minus 1 and x minus 4. So we have a common factor here, which is x minus 1. We can cancel that out. That is equal to 1. And take note that the factors that are being cancelled in a rational function reduce, when it is already reduced, represents the whole in the graph, or it represents the holes in the graph. Okay, so after simplifying this one, we can now have the reduced function, which is y is equal to x minus 3 over x minus 4. So this will be the reduced function for this rational function, or the reduced rational function, x minus 3 over x minus 4. So this is now our reduced function. So for step 2, we're going to find the vertical and the horizontal asymptotes. To find the vertical asymptotes, all you have to do is to equate the denominator by 0. So you will have x minus 4 is equal to 0. Therefore, x is equal to 4. So this is now your vertical asymptotes. For the horizontal asymptotes, we will be comparing the exponents of the numerator and the exponents of the denominator. Since they are equal, so we will get the leading coefficients, the value of a and b. So here we will have 1 over 1 or 1 divided by 1. So your horizontal asymptotes will be y is equal to 1. And then we're going to draw it in the graphing paper. So your x is equal to, for the vertical asymptote is the blue one, and the horizontal asymptote y is equal to 1 is this one. Okay. For step number 3, we're going to find the intercepts and zeros of the rational function. So the x and the y intercept. To find the x-intercept, we will let the value of y equal to 0. So we will be using the reduced function f of x is equal to x minus 3 over x minus 4. So this one, so let y or f of x be 0, and then cross multiply 0 times x minus 4, that will be 0, and x minus 3 times 1 will be x minus 3. So you will have this one, and then your x-intercept will be 3. Now, we will find the coordinates since x is 3 and y is 0, so the coordinates will be 3, 0. Now, to find the y-intercept, we will let the value of x this time equal to 0. So, you will have this one, substitute 0. So, therefore, you will have negative 3 divided by negative 4. Your y-intercept is positive 3 over 4. And the coordinate, okay, the coordinates will be 0 and 3 over 4. So, x is 0, y is 3 over 4. And for the zeros of the rational function, this is the same as your x-intercept. Okay? The zeros of a rational function is also the x-intercept. Now, plotting this one, you will have 3, 0 in the Cartesian plane. This will be point A. And you have 0, 3 over 4, that will be your point B. So, na-plot na natin yan together with the asymptotes. Now, for step number 4, we're going to determine the domain and range. Since this is not a set, we cannot easily determine the domain and range, but we will be solving for this one since it is a function. So, to find the domain, all we have to do is to solve for y in terms of x. So, we'll be using the reduced function y is equal to x minus 3 divided by x minus 4. So, this is already in y in terms of x. So, we don't need to solve this one. We will simply determine the domain. So, we will look for the value of x that will make this undefined, and that will be the restriction. So, equating this one, x minus 4, which is also your vertical asymptote, guys. So, you will have here, the domain is all real numbers except 4, or in symbol, x is not equal to 4. So, any number could be a value of x except 4. So, this is how you find the domain. For the range, it's the other way around. So, you're going to solve for x in terms of y. So, again, using this function, so cross multiplication, we will have now y times the quantity x minus 4 is equal to x minus 3. And then distribute this one, you will have xy minus 4y is equal to x minus 3. Since we are solving for x, we combine similar terms by transposing x to the left side and negative 4y to the right side. So we will have xy minus x is equal to 4y minus 3. So, and then we factor out x here. So that will give you x times the quantity y minus 1 is equal to 4y minus 3. And then, to make it x na lang, you will divide both equation by y minus 1. So we can cancel now y minus 1, and then this will be your resulting functions. Now, so since this is already in x, the x in terms of y, so again, look at the denominator. So your denominator is y minus 1, equating this to 0. Y minus 1 is equal to 0. You will have the value of y, which is 1. So that will be your restrictions. So your range will be any real numbers except 1, or y should not be equal to 1. So this is how you find the domain and the range of any rational function. Okay, since we know the restrictions, x should not be equal to 4 and y should not be equal to 1, so we will make now the domain and range by using a table of values. So at 4, it will be undefined. Okay, so, and y should not be equal to 1. So, we let any values, since I assigned here for values of x, the domains 1, 2, 3, 4, 5, 1, 2, 3, and then 5, 6, 7 because 4 is not included. So, we'll just simply solve for y. So, substitute natin siya, 1 here, 1 minus 3, and then divided by 1 minus 4, that will give you 2/3. And then for 2, you have 2 minus 3 divided by 2 minus 4, that will give you positive 1/2. And then if it is 3, we know that this is already also your x-intercept, so you will have 3, 0. And then there is your vertical asymptote, x is equal to 4. And then for 5, you will have 5 minus 3 over 5 minus 4, that will give you 2. And then if x is 6, you will have 6 minus 3 divided by 6 minus 4, so you will have 3 over 2. For 7, you will have the value 4/3. And if x is equal to 8, you will have 5 over 4. So we will now plot these points in the Cartesian plane. So step number 5 will be sketch the graph. So this is now the plot of points. So this is your horizontal asymptote, the blue one. The vertical asymptote x is equal to 4. The horizontal asymptote y is equal to 1. And these are the points. Okay. So if you will notice, these points are going down. If you will continue getting assigning values for x and solving it, you will have here a continuous graph going down, and for this part you will have a continuous graph to the positive infinity. So connecting the dots, this will be your graph. Yan. So this is how it looks like. So here the orange one is your vertical asymptote, x is equal to 4, and the blue one is your horizontal asymptote, y is equal to 1. So even if you extend the graph, the smooth curve, the green one, it will not touch the horizontal and the vertical asymptote. It looks like here nagta-touch sila because the picture here is stretched out, but it will never intersect. Okay, so this is the steps in finding or in graphing rational function. I hope you did follow the instructions. All you have to do is to recall or to go over with step 1 up to step 5 so that you can determine it. You can plot them one. Okay, this ends our discussion. Kindly visit the Google Classroom for your output. If hindi pa kayo nakasubscribe, please subscribe, and then you can share this one to anyone you know na tingin nyo ay makakatulong sa kanila, especially the senior high school students. So, thank you.